Hello, my name is METİN. This is 254th part of explanation of my theory. According to my theory and my formulas, electron rest mass is not 9.11 10 to the minus 31 kilogram. Yes. On which scale can we weigh an electron? Moreover, is there any possibility of us seeing an electron as a whole, like ordinary observable objects? Or do we just experience its point effects? 1. The rest mass of an electron, which is thought to have been measured as a whole until now, is actually the mass of an inseparable point on it. I defined this point as a photon. So, what accepted physics experiments measure as the rest mass of an electron is actually what they measure as the mass of a point of the moving electron. This mass that they think they measured as the rest mass of the electron is 9.10 to the minus 31 kilogram. Is it true? 2. On the one hand, accepted physics theories claim to measure the rest mass of the electron. On the other hand, they are unaware of the consequences of making this measurement by moving, accelerating the electron. 3. According to me, the moment you move, you accelerate an electron, the mass you measure is no longer its rest mass. As you move, as you accelerate the electron, you change its point mass. This fact has nothing to do with Heisenberg uncertainty fiction. If an electron motion form is in motion, its shape changes. One of my formulas about accelerated electron motion forms, shortened wavelength formula, is here. I advise you to notice that. Yes. Snapshot. For instance, if we apply 5,000 volts to accelerate an electron motion form, according to my formula, shortened wavelength will be what? Will be 0.24966 nanometer. Here. And according to my photon point mass formula on the surface of an electron motion form here, in short, shortened wavelength point in this point, lambda minus delta lambda, not this point, lambda plus delta lambda, opposite direction, motion direction, 0 degree direction, lambda minus delta lambda. If electron motion forms point arbitrarily, we choose that, this photon, not this photon, not this photon, okay. Photon is a marked arbitrary imaginary point on totally motion surface of electron motion form, and for this point, for instance, mass is 1 point in c direction, in linear velocity direction, component mass, linear velocity component mass will be 1.4085 10 to the minus 33 kilogram here. Okay, I advise you to notice. Yes. This wavelength is not at rest electron motion forms wavelength at this point, at this point, at this point, for instance, at this point, okay? Because when we make electron motion form accelerate, its point masses change. 4. As I told you before, if an electron motion form is in motion, masses, wavelengths, wave velocities, angular momentums, energies of an inseparable point on its surface motion change, depend on electron motion form's velocity, direction, and orientation. In this case, at each surface motion point, mass of revolving photon on the surface motion of electron motion form changes. Its energy, wavelength, wave velocity, angular momentum, etc. change. Eventually, if we accelerate an electron motion form, its photons, masses change. So we cannot say that this is the rest mass of an electron. Thus, because in both Thomson charge to mass ratio experiment and Millikan oil drops experiment, as soon as they apply voltage to accelerate the electrons, photons masses will change. From this moment on, there can be no talk of rest mass of electron. 5. Can there be a method to measure the mass of a point on an at rest, not relocating electron? If this method can be found, what will be the mass of a point of an electron in kilograms. There is no need to go far. We can find a simple method right away. Do you remember ground state energy of hydrogen atom? Okay. Here, red cycle proton intertwined with electron, single electron, intertwined. This is electron motion form, one proton bound electron motion form of a hydrogen atom. Electron is not revolving around a proton. Its surface and arbitrary a point revolves in special conditions. Yes. Do you remember ground state energy of hydrogen atom? Minus 13.6 electron volt. For instance, here, remember, according to me, not minus, 13.6 eV, okay? This energy state is undisturbed state of a hydrogen atom. In the same time, this is the ionization energy value of a hydrogen atom. According to me, contrary to accepted physics theories, A. Electron is not dimensionless point particle, it has a certain wavelength. B. An electron never revolves around a proton. Instead, its inseparable point photon revolves around a proton in special conditions. Electron only makes joint motion with a proton in an atom. They, proton and electron motion form intertwine. Yes, but don't forget, electron motion form is not relocating. It is at rest but cycling in all directions as a spherical ring shape motion. And a photon, an arbitrary imaginary point on this motion, total motion surface, okay. But electron is not revolving as a whole around the proton. This picture is wrong, okay? See, for instance, 13.6 electron volt represents energy of a point on the surface of an at rest, undisturbed electron motion form with 178 nanometer. In somewhere my former videos, 91.155 nanometer approximately. Here 91.178 nanometer. Okay, and therefore linear velocity component mass of photon of at rest electron motion form according to my proton masses formulas for non-relocating electron motion form. In short, okay, here I advise you to notice snapshot. Okay? And therefore linear velocity component, mass of a photon of at rest electron motion form is 3.83 14 × 10⁻36 kg. Here, linear velocity component, and speed of light component, c direction component, mass of a photon of at rest electron motion form is 2.42 24 10⁻35 kg. Eventually, point mass of an at rest electron motion form in c component direction is 2.42 10⁻35 kg. In linear velocity component direction is 3.83 10⁻36 kg. These numbers are different, and electron motion forms, at rest electron motion forms, point mass is not 91 point. I'm so sorry. And at rest electron motion's point mass is not 9.11 10⁻31 kg. Have a good afternoon. See you later.